Welcome to The Explainer. Today, we are going to break down 3 classic Python coding challenges. We're going line by line from a simple text counter to a really clever prime number checker. The whole point is to help you learn how to think like a programmer. So here's our game plan for today. We'll kick things off with a classic vowel counter. Then we'll level up to a prime number checker, and I'll show you a really smart optimization. After that, we'll see how a tool called a dictionary can make a tricky problem super simple. And finally, we'll wrap it all up by putting these ideas into a powerful programmer's toolkit.
All right, let's jump right into our first challenge. This is one of those text processing tasks that pretty much every programmer comes across at some point. It's a fantastic way to get a handle on some really fundamental concepts.
Okay, so mission number 1, count the vowels in any given string. But here's the catch. It has to be case insensitive. That means a capital A counts just the same as a lowercase a. So if you take hello world, for example, we'd count the E, the O, and the other O, giving us a grand total of 3. First things first, we define our function, count vowels. Then, right inside, we set up our tools. We've got a simple string called vowels that just holds all the characters we're hunting for. And then we have our count variable, which is basically our scoreboard, and we're going to start it at 0. Now this next line, this is a total game changer. Instead of writing a bunch of code to check for A and E and so on, we just solve the whole case-sensitive problem in one clean shot. We convert the entire input string to lowercase. This is a technique called normalization, and it is absolutely critical in everything from search engines to big data analysis. Okay, so now that our text is all nicely standardized, we can just loop through it one character at a time. And for each character, we ask a simple question. Is this character in our vowels string? If the answer is yes, we just bump our counter up by 1. If not, we just move on to the next one. Simple, right? And this is really where Python's in operator just shines. It's so elegant. It's like asking, hey, is this person on the guest list? Instead of having to read out every single name on the list to see if there's a match. It's an incredibly powerful and clean way to check for membership, and it keeps our code so much more readable. Let's just quickly walk through the word hello to see this thing in action. First up is H. Is that on our vowel list? Nope. So the count is still 0. Next is E. Yep, that's a vowel. The count is now 1. Then we get an L. Nope. Another L. Still nope. And finally O. Yes, that's a vowel. The count goes up to 2, and we're done. Okay, now that we've totally nailed the vowel counter, let's tackle something a little bit trickier. We're going to build a prime number checker, and this one is really going to test our logical thinking and show us the incredible power of optimization. All right, next up, the prime number checker. So as you probably remember, a prime number is any number greater than 1 that's only divisible by 1 and itself. Think 7. But a number like 10 isn't prime because, you can divide it by 2 and 5. This is going to take some pretty smart logic to solve efficiently. First, let's just handle the easy stuff, right? The edge cases. By definition, any number that's less than 2 just can't be prime. So this simple if statement gets them out of the way immediately. It's a quick win that saves us a ton of unnecessary work down the line. Okay, now here is where we get really smart. Instead of checking for divisors all the way from 2 up to the number itself, we only need to check up to its square root. This is a huge optimization. We're talking about a massive reduction in work for the computer, especially when you're dealing with really large numbers. So you're probably asking, why the square root? It might seem a little random, but trust me, there is a super clever mathematical reason behind this trick. Let's break it down. So here's the key. Factors always come in pairs. Let's take the number 36. Its factors are 2 and 18, 3 and 12, 4 and 9. Now, the square root of 36 is 6. Notice how in every single one of those pairs, one of the factors is always less than or equal to 6. So, by only checking up to the square root, we are absolutely guaranteed to find the smaller factor in any pair. And that's all we need to prove a number isn't prime. So inside our loop, we use this little guy, the modulo operator, that percent sign. All it does is give us the remainder of a division. So when we say n%i equals 0, we're just asking, hey, does n divide by I with absolutely no remainder? And if the answer is yes, even just once, we found a divisor. Game over. We know it's not prime, and we can just stop right there and return false. For our final challenge, we're going to see how picking the perfect data structure can turn what seems like a complicated counting problem into, well, a piece of cake. This is a technique that I promise you will use all the time in real-world programming. Our last mission is to create a character frequency count. So for a word like banana, We want our function to tell us that B shows up once, A shows up 3 times, and N shows up twice. We need a way to store both the characters and their counts together. And the absolute perfect tool for this job is a Python dictionary. It works just like a real dictionary. You look up a word, that's the key, to find its definition, that's the value. In our case, each unique character will be a key, and its running count will be its value. So let's build it. The setup is really simple. We define our function, we create a brand new empty dictionary called freak_dict, and then, just like we've done before, we start looping through our input string one character at a time. And here's the heart of the whole thing. For every single character we look at, we just ask one question. Have we seen this character before? If it's already in our dictionary, we just find it and add 1 to its count. If it's brand new, we add it to the dictionary for the first time and set its count to 1. That's literally all there is to it. So, after tackling those 3 challenges, what have we actually learned? Well, it turns out we've just uncovered some incredibly powerful, fundamental strategies that you can use to solve all sorts of programming problems. Let's add them to our toolkit. Okay, here are the 3 big takeaways. Number 1, always normalize your data first. Cleaning up your input, like we did with .lower, makes everything that comes after so much easier. Number 2, always be on the hunt for optimizations. Thinking smarter, not just harder, like with the prime checker, saved us a ton of work. And number 3, pick the right data structure for the job. The dictionary made that frequency count an absolute breeze. Keep these 3 ideas in your back pocket and you'll be a much more effective programmer. And believe me, this isn't just about solving little coding challenges. That character frequency algorithm we just wrote? It's a fundamental building block used in real-world applications all over the place, in data compression like zip files, in cryptography, and in analyzing massive amounts of text. These fundamentals are what powerful software is built on. So, I'll leave you with a final challenge. We've built 3 powerful little tools today. How could you chain them together? How would you combine these ideas to solve a bigger problem, like analyzing the frequency of only the prime digits, so 2, 3, 5, and 7, inside a massive text file? You have all the building blocks now. It's up to you to put them together.